Hello everyone, I'm Suraj. I'm a BCom graduate and I did my MBA from Xavier Institute of Management, Bhubaneswar in the year 2009-11. After my MBA, I went on to work with ICICI Bank and worked there for 1.5 years and also managed a portfolio of 400 crores there. Now, it's been close to 10 years that I've been engaged actively in training and mentoring students. I've trained around 10,000 plus students from various backgrounds like BTech, BBA, BCom, BA as well. I also hold the distinction of training a visually impaired student who ended up getting a 99.6 percentile in CAT and is an alumnus of IIM Ahmedabad. I've helped a lot of my students get into IIM Ahmedabad, Bangalore, Calcutta, and a lot of other top MBA colleges over the last 10 plus years. Now, in order to guide my students effectively and also to understand the trends of the examination, I make it a practice that I write CAT every year and I ensure that I get a 99 plus percentile in the QA and LRDI section of CAT. Now, what's in this video today? Now, in this video, I've brought in a very interesting and a very important topic from CAT's point of view, which is speed, time, and distance. So, this video will have complete concepts of speed, time, and distance. And I've also brought in last 5 years questions of speed, time, and distance, and I've also segregated them model wise. So, every part will have a concept as well as questions. So, we'll learn the concept. We'll also learn the important points that we need to keep in mind before we go to the examination hall. See how do we apply the concepts in the actual CAT questions which have been coming up in past years. And after that, I'll also be giving you certain tips and tricks which will help you to understand the topic better and also score well in the examination. Let's get started. So let's look at the first model, which is the most basic model. You won't believe that a good number of questions have come from this model. And the beauty of this model is there's nothing to do much. All that we'll deal with this model is, the word problems. Right. So this model is as simple as understanding the formula of speed. And we know that the formula of speed is distance upon time. Now, what are the things that we need to keep in mind? That the uniformity of units is very important. That means if the distance is in meters, right, the time should be in seconds and the unit of speed becomes meters per second. Similarly, if the distance is in kilometers and the time is in hours, then the unit of speed becomes kilometers per hour. So this uniformity is generally tested here apart from the word problems. Now, we also need to be good at the cross multiplication formula, right? So therefore, we know that distance is equal to speed into time, and we should also know that time is equal to distance by speed. Now, what are the other things that we need to remember in this model? There's the conversion, because we have two generalized units of speed. If I'm given x kilometers per hour, if I'm converting that in meters per second, right, then all that I do here is going to be I multiply x with 5 by 18 and I get this unit is in meters per second. Similarly, if I'm given, let's say, k meters per second, if I need to convert that into kilometers an hour, then the simple conversion becomes k into 18 by 5. Right? So in last 5 years, the best part is around 7 to 8 questions have come up in this model. And the best part in this model is nothing is to be done. All that we are using is the basic formula and we will be given word problems. So all we have to look at is how to convert English into mathematics. Let's start solving. Yep. So this first question which had appeared in CAT 2002 slot 2. So two ships meet mid-ocean and then one ship goes south and the other ship goes west. So if this is the point where they met, one ship is going south, that is down, and the other ship is going west, that is on the left side. Clear? Now both of them are traveling at constant speed. 2 hours later, they are 60 kilometers apart. So when I say 60 kilometers apart, this distance is 60 kilometers and this becomes a right angle triangle. Clear? Now, if the speed of one ship is 6 kilometers an hour more than the other ship, so let's say the smaller ship speed is x. So in 2 hours, it would have covered 2 into x kilometers. And the other ship speed is 6 kilometers an hour more, that becomes x plus 6. And I'm multiplying with 2 here. Clear? So therefore, this becomes a distance that is 2 into x plus 6. Now, whenever we have right angle triangle, the first thing we try to use is the triplets, right? Now, one more thing that we need to understand is if one of the sides is 2x plus 12, clear? And the other side is 2x and the third side is 60 and 60 is the hypotenuse. That means the difference between these two sides is going to be 12 kilometers. So let's try to understand triplets. If I take triplets called 3, 4 and 5, and since the hypotenuse is 60, if 5 parts is equal to 60, that means 1 part becomes 12. So 4 parts will be 4 into 12, that is 48, and 3 parts will be 3 into 12, that is 36. And the best part we are seeing is that the gap between these two is also 12 kilometers an hour. So need not solve a quadratic equation by using Pythagoras theorem. This becomes a simplified format. That means 2x will be 36, 2x plus 12 will be 48, and the third side we know is going to be 60. Now the question is asking you find the speed of the slower ship. Now I know that the slower ship speed is x. So in 2 hours, it has traveled 2x kilometers, which is 36. So the value of x becomes 18, and x is the speed of slower ship in kilometers an hour, and therefore 18 becomes our required answer. So very simple question, nothing to be done. All we need to know is Pythagorean triplets, right? And then once we know the Pythagorean triplets, our job becomes easy to solve. Let's look at the next question here. Now, this question says the distance between A to B is 60 kilometers. So, let's understand it with the help of a number line. So, distance between A to B is 60 kilometers. Right. Now, Bharat and Narayan start from A at the same time and move towards B. So, I'm talking about A and I'm talking about B. Both of them start from A and move towards B. Clear? Bharat take 4 hours more than Narayan to reach B. So, what am I given here? So, I'm given that the time taken by Bharat is 4 hours more than the time taken by Narayan. This is the first equation statement. Now, moreover, Parath reaches the midpoint of A and B 2 hours before Narayan reaches B. That means the time taken by Parath, let me write the second equation here. The time taken by Parath to reach the midpoint, okay, let me write MP, is equal to 2 hours before the time taken by Narayan to cover the distance AB. Now, what is the question asking us? The question is asking us find the speed of Parath. So, I am given distance, clear? And the relationship is talking about time. So, if I assume the speed of Parath and Narayan, my job becomes easy. So, let's try to understand. Let me assume the speed of Parath to be P and speed of Narayan to be N. So, from the first equation, 60 divided by P is equal to 60 divided by N plus 4. Clear? Time taken as distance by speed, right? Well, the time taken by Parath is equal to time taken by Narayan plus 4. Now, time taken by Parath to reach midpoint. When I say midpoint, that means now Parath is covering 30 kilometers. So, 30 by P is equal to time taken by Narayan to reach B becomes 60 by N minus 2. 2 hours less than this. Now, what I can see is 60 by N and 60 by N is common. So, I can cancel both of them. So, this becomes minus, and this becomes plus. So, these two get cancelled here. So, 60 by P and 30 by P, clear, minus. So, I have 30 by P here, and 4 plus 2 becomes 6. So, 6 ones are 6 fives are, or eventually what do we have? We have the value of P is equal to 5 kilometers per. So, therefore, this becomes the speed of Parath, and we can get in the easiest possible manner. There are many ways to do it, but trust me, if you ask me, this is the most easy way in which you can get this answer. Clear? Let's look at one more question here. Now, we are given that point P lies between points A and B such that BP is thrice of AP. Okay. So, I have A, I have B, and I'm told that BP is thrice of AP. That means AP is a smaller part. Let me assume the distance of AP is x. So, distance of BP becomes 3x. Clear? Now, I'm told that car 1 starts from A and move towards B. Similarly, car 2 starts from B and move towards A. Okay. So, car 1 starts from here and car 2 starts from here. Both of them are moving towards each other. Now, car 2 reaches 1 hour after car 1 reaches P. That means what am I given? The time taken by car 2 is equal to 1 hour more than the time taken by car 1. Clear? And I'm told that speed of car 2 is half that of car 1. So, car 2 is half that of car 1. So, let me assume speed of car 2 is S. So, car 1 is S. So, speed of car 2 becomes S by 2. Clear? Right? So, car 2 reaches P. So, both of them are reaching P here. Okay. So, 2 reach P. Now, the time taken by car 1 to reach P from A is how much? Now let's try to understand. Time taken by car 2 to reach P becomes 3x divided by S by 2 is equal to car 1 to reach P becomes x by S plus 1. And we want the time taken by car 1 to reach P. That means we want the value of x by S. Now let's simplify this. If we simplify, this becomes 6x by S is equal to x by S plus 1. Or what do we get here? We get 5x by S is equal to 1. Or we eventually get x by S is equal to 1 by 5 of an R. Clear? We get 1/5 of an R. Now the question is asking us, and we wanted x by S only. So the question is asking us, find the time taken by car 1 to reach P from A, which is in terms of minutes. So 1/5 of an R becomes 1 by 5 into 60, which means it's going to take 12 minutes to reach from for car 1 to reach from A to P, and this becomes our simplified answer. So you can see, guys, that the questions are very simple. Right, we need not do too much. All we have to understand is the units should be uniform, assume the values, and eventually get your required answers. Let's look at the next question here. Now, I'm told that the distance from B to C is thrice from A to B. Okay. Now, what would my advice be is, whenever I'm solving a question, my advice would be is to pause the video, solve it on your own, and then come down to this for a solution. Right. The distance from B to C is thrice that of A to B. Two trains travel from A to C via B. Okay, so I have A to C. There's a B to C is thrice from A to B. Okay, so this is B. So B to C is thrice. So let me assume this distance is D. So this distance becomes 3D. B to C is thrice that of A to B. Perfect. Now two trains, speed of train 2 is double that of train 1. Okay, so let's say train 1 is equal to S. So train 2 is equal to 2S. Now both of them are traveling from A to C. Okay. While traveling from A to B, and their speeds are interchanged. Okay. So I have something else here. So let's write it this way. So from A to B, the speed of train 1 is equal to S and train 2 is equal to 2S. Right? From A to B. And their speeds are interchanged by traveling from B to C. That means now T1 now becomes 2S for this part of the journey, and T2 will be S for this part of the journey. The ratio of time taken by train 1 to that of time taken by train 2 to travel from A to C. That means I want the ratio of time taken by train 1. What is the time taken by train 1? That is D by S from A to B. Clear? Similarly, from B to C will be 3D by 2S, which is equal to time taken by train 2 becomes D by 2S plus this would give me 3D by, now I can take D by S common on both the sides. Sorry, I want the ratio, right? If I want the ratio, this is what we want. I can take D by S common on this side. So this becomes 1 plus 3 by 2 is 2. Again, I can take D by S common on this side. So this becomes 1 by 2 plus 3. So D by S gets cancelled. So I have 1 plus 3 by 2 becomes 2 by 2 plus 3 by 2, which is 5 by 2 is 2. 1 by 2 plus 3 becomes 6 by 2. That becomes 7 by 2. Clear? So 2 and 2 gets cancelled. So therefore, my final ratio is again a very simple question. The final ratio is going to be 5:7, and therefore option D becomes our required answer. So again, not a difficult question, a simple question to look at, and all we need in the examination is try to identify these kind of questions and convert them in the examination. Right? Let's move to the next question, please. Now, points A and B are 150 kilometers apart. Okay. Cars 1 and 2 travel from A to B, but car 2 starts from A when car 1 is already 20 kilometers away. Okay. So car 1 is already 20 kilometers away. So car 1, let's say, starting from here, that is 20 kilometers away, and car 2 is starting from here. Each of the car travels at a speed of 100 kilometers an hour for the first 50 kilometers. 50 kilometers an hour for the next 50 kilometers, and 25 kilometers an hour for the last 50 kilometers. The distance in kilometers between car 2 and B when car 1 reaches B. Now, let's understand what is happening. So, car 1 has to reach B. So, I'm told that 100 kilometers an hour for the first 50 kilometers. Now, car 1 has already crossed 20. So, car 1 will travel 30 by 100. This is the time taken for the first 50 kilometers. I repeat, 20 kilometers is already done. For the next 50 kilometers, it's traveling at 50 kilometers an hour. And for the last 50 kilometers, it's traveling at 25 kilometers. This is by car 1. Okay. Time taken by car 1. Now, let's try to understand time taken by car 2. Now, what is time taken by car 2? Time taken by car 2 ideally should be 50 by 100 plus 50 by 50 plus 50 by 25. Now, what is the difference? If you observe, when car 1 reaches B, I want to know where is car 2. That means car 1, the time gap between car 1 and car 2 is only 20 kilometers. Clear? And car 1 is traveling at a speed of 100 kilometers an hour. So, in terms of minutes becomes 1 by 5, 1 by 5 becomes, that means car 1 is 12 minutes ahead of car 2. So, when car 1 is 12 minutes ahead of car 2, which means when car 1 reaches B, car 2 will be 12 minutes behind the reaching point. I repeat, when car 1 reaches here, car 2 will be somewhere here, wherein the car 2 will have to travel for 12 minutes. So, this distance will be the distance traveled by car 2 in the last lap of 12 minutes. So, 12 by 60. Clear? 12 by 60. And the last lap, car 2 will travel at a speed of 25 kilometers an hour. So, this becomes 1 by 5, 5 ones are 5 5s are. That means the distance of gap between car 1 and car 2 when car 1 reaches B is going to be 5 kilometers, and that's going to be our required answer. Clear, guys? So, this is what is going to be our required answer here in this case. And let's move to the next question, please. Now, let's look at this question. Now, the question says that Vimla starts for office every day at 9 a.m. and reaches exactly on time if she drives at a usual speed of 40 kilometers an hour. She is late by 6 minutes if she drives at 35 kilometers an hour. This is a standard speed, time and distance question. In this case, the distance traveled in both the cases is same, right? So, let's say the usual time taken by Vimla is t minutes. So, when she is traveling at 40 kilometers an hour, the time taken becomes t divided by 60. So, speed into time becomes the distance part. Now, the same distance is traveled when she is traveling at 35 kilometers an hour, but this time the time taken is 6 minutes more than the previous time. So, this 60 and this 60 gets cancelled. This is 8s and this is 7s. So, all we get is, this is in brackets. So, all we get is 8t is equal to 7t plus 42, or we get the usual time taken is equal to 42 minutes to reach the office in usual time, right? So, what is the distance? Because the next part says one day she covered 2/3 of the distance. So, let's calculate the distance also. So, the distance is going to be 40 into 42 divided by 60. Clear? So, this is going to be 6 7s are 6 10s are, and 0 0 gets cancelled. So, the distance is going to be 28 kilometers. Now, one day she covered 2/3 of the distance in 1/3 of her usual time. That means she covered 28 into 2 by 3 is the distance that she has covered in the time that is 1/3 of 42, which is going to be 14 minutes. Clear? And then she stopped for 8 minutes. That means she is stopping for 8 minutes. So, that means the total time taken is going to be 22 minutes of the time is elapsed, right? The speed at which she should drive for the remaining distance. If 2/3 of the distance is covered, remaining distance becomes 28 into 1 by 3. To reach office exactly on time. Now, exactly on time is 42 minutes. Out of that, 22 minutes are already done. That means she has to cover this distance in 20 minutes. And we need the speed, and we know that speed is distance by time. So this is 28 into 1 by 3 divided by 20 minutes. If I convert in the hours format, that becomes divided by 60, which is again 1 by 3. So 1 by 3 and 1 by 3 will get cancelled. That means she has to travel at 28 kilometers an hour to ensure that she's covering the distance on time, and therefore our answer here becomes option B. Clear? So this is what we are seeing, guys, that the first model, which is the basic model, all the questions that have been coming up in last 5 years, none of the questions were difficult. So if we are getting a question of this kind, almost every year we have seen one question coming up from this. So our job is to see that we are becoming very good at the word problems so that we become masters of it, and at least we're able to grab this one question in the least possible time. Right? Now let's look at the next question, please. Now one can use three different transports which move at 10, 20, 30 kilometers an hour. So I'm moving at 10 kilometers an hour, 20 kilometers an hour and 30 kilometers an hour to reach from A to B. Now Amal took each mode of transport for 1/3 of the total time. Now let me assume that total time, okay, is equal to 3t. So each part is 1/3, 1/3, 1/3. So I have speed and I have time. So what can I calculate? I can get the distance. So what is the distance covered? The distance covered here becomes 10t. The distance covered here becomes 20t. And the distance covered here becomes 30t, which means the total distance becomes 60t. Clear? This is Amal. This is done by Amal. Now what is Bimal doing? Now Bimal took each mode of transport for 1/3 of the total distance. That means Bimal is traveling 20t at a speed of 10 kilometers an hour, another 20t at a speed of 20 kilometers an hour, and last 20t at a speed of 30 kilometers an hour. Now the percentage by which Bimal's time exceeds Amal's time travel is nearest to what? Okay. So I want Bimal's time exceeding. So what is the time taken by Bimal? Let's see. This plus this plus this. So this is t plus this is 2t plus this is, sorry, t, yeah, this is 2t by 3. Which means the time taken by Bimal becomes 3 plus 2t by 3. This is time taken by Bimal. And what is the time taken by Amal? The time taken by Amal is going to be, this is, sorry, 3t. The time taken by Amal is 3t. So what is the percentage gap? The percentage gap is 2t by 3 divided by 3 multiplied by. Clear? So 2t by 3 divided by 3 multiplied by 100 will actually give us how much, guys? So will actually give us 2 by 9 into 100, and 2 by 9 into 100 is going to be 22.22%. So therefore our answer here becomes 22.22 should be the required answer in this question altogether. Clear, guys? Again, not a difficult question, very easy question. Let's look at the next question, please. Now, two trains leave station X for station Y at 3 p.m. Let's start from here now. So I have station X, I have station Y, so I have train T leaves at 3 p.m. Train S travels at 3/4 of the speed of train T, that is 3/4, right? So let me assume that the speed of train T is 4s. Sorry, we cannot take S because this is already being mentioned. So let me take this as 4k. Okay. So what is train S doing? Train S is traveling at 3/4 of the speed, that is 3k, and it started at 4 p.m. This is what is given to us. Two trains pass each other at station Z. Okay. So when they cross each other, let's say this point is station Z. Okay. Where the distance between station A, between X and Z is 3/5 of the distance between X and Y. Now let me assume the distance between X and Y is 5d. So X and Z is 3/5, that becomes 3d, and this part becomes 2d. Now what can you comment when two people are meeting? I can say that the time taken by train T to cover XZ will definitely be 1 hour more than the time taken by train S to cover Z and Y. Let's take an example. Suppose they are meeting at 5 p.m. Suppose. So this train had traveled from 3 to 5. That means this train had traveled for 2 hours, whereas this train has traveled for only 1 hour. Clear? So if they are meeting at 6 o'clock, then this train would have traveled here for 3 hours and this train would have traveled here for 2 hours. So in every case, what we are seeing that the time gap is 1 hour. Clear? So if the time gap is 1 hour, so therefore I know that the time taken by train T to cover XZ, that is 3D by 4K, is equal to time taken by S, that is 2D by 3K plus 1 hour. So if we simplify, or if we make, so what we do is here, 3D by 4K minus 2D by 3K is equal to 1. So the LCM becomes 12K, and this is 9D minus 8D is equal to 1, or we have D by K is equal to, D by 12K is equal to 1. Okay. This is what we get. Now, what is the question asking us? How many hours does train take to travel from X to Y? So what do I want? I want 5D by 4K. That means I want 5 by 4 into D by K. So what do I have from here? I have D by K is equal to 12 that I have from here. If D by K is equal to 12, that all I need is 5 by 4 into 12. So this is 4 ones are 4 threes are. So time taken here becomes 15 hours should be the time taken by train T to cover the journey from X to Y. And that becomes our final. Right, guys? So this was all about the model of basic model, where we have seen that every model, every year we have seen one question coming up from this model. So my advice would be is to be thorough with this. Only thing to keep in mind is how to frame the equation. Point number 2, uniformity of units, and then you're done with this. And I can assure you that one question in every year we can solve with the help of basic calculation model. Right? So let's move to the next model, which is the proportionality model, the most important crux of this topic. Now in proportionality, we look at three things: when distance is constant, when time is constant, and when speed is constant. So what happens when distance is constant? When distance is constant, speed is inversely proportional to time. When speed is inversely proportional to time, we write S1 by S2 is equal to T2 by T1. Similarly, when time is equal to constant, we know that distance is directly proportional to speed. So we write D1 by D2 is equal to S1 by S2. Similarly, when speed is constant, we know that time is directly proportional to distance. So we write T1 by T2 is equal to D1 by D2. Now, when do we use proportionality? Now, suppose the question is mentioning about the same distance and the question is not asking you the value of distance. Because understand, when I take distance as constant, I am eliminating distance from the scene. Right? So all that we need to do is that if the question is saying distance is constant and the question is not talking about distance anymore, we use proportionality. Else, the best model is the basic model. Because generally students waste their time a bit to calculate these questions and then eventually the time is being wasted. So we have to just understand this, that proportionality is generally used over the basic method when something is constant and something is not spoken of. Suppose distance is constant and I want you to calculate the distance. How do I calculate the distance when I'm equating speed and time? Then definitely I'll go a slightly longer method and calculate the value of the distance there. Right? So let's look at these questions here. Let's look at the first question here. Now, a cyclist leaves A at 10 a.m. and reaches B at 11 a.m. Okay. Starting from 10:01, every minute a motorcycle leaves A and moves towards B. Now 45 such motorcycles reach B by 11 a.m. Okay. All the motorcycles have same speed. If the cyclist doubled the speed, how many motorcycles he would have reached by the time the cyclist reached B? Now, why is this question in here this model? Because I am told that initially the speed was S and now the speed became 2S for the same distance. That means distance is constant. When distance is constant, we know that speed is inversely proportional to time. Got the logic here? Right? So if the ratio of the speeds is 1:2, this is the ratio of speeds. That means the ratio of time taken becomes 2:1 this time. Clear? If the speed is doubled, the time taken becomes half. So if earlier the cyclist was starting from 10 to 11, that means he was taking 1 good hour. Now he has only 30 minutes of time that is asked in the question. All the motorcycles have same speed. If the cyclist doubled his speed, how many motorcycles would he reach by the time the cyclist reached B? That means how many motorcycles would he cross in 30 minutes of time? Whereas the motorcycle speed is same. Now let's understand from motorcycle's point of view. Now what is happening here? The first motorcycle started at 10:01, the second motorcycle started at 10:02. Similarly, the last motorcycle started at 10:45. And it reached B at 11 o'clock. So can I say the time taken by each motorcycle is 15 minutes? Clear? Right? Because 10:46 will reach at 11:01 and I'm not bothered about that 11:01. I'm all bothered about 10:45. It is reaching by 11 o'clock. Clear? Right? Now, so if I have time from 10 o'clock till 10:30 in the second case, and the motorcycle speed is not changing, which means the motorcycle will still take 15 minutes to reach. Right? So, all that we can look at is, I know that the last motorcycle, which is starting at 10:15, will reach B at 10:30. Because anybody starting at 10:16 will reach beyond 10:30, right? So that means I'll meet all the motorcycles from 10:01, 10:02 and so on, so on, so on till 10:15. That means how many motorcycles am I meeting? I'm meeting 15 motorcycles. Clear? 15 motorcycles and half the time that I was taking earlier because my speed has doubled, clear, in to encounter the motorcycles, and therefore the answer here becomes option C, that is 50. Right? Let's look at the next question. Now, two cars travel the same distance. Now, that's the best part. Okay, same distance. That means distance is constant. One starting at 10 o'clock, another starting at 11 o'clock on the same day. They reach the common destination at the same point in time. Beautiful. Okay. So we have starting at 10 o'clock. The other one is starting at 11 o'clock. Okay. But both of them are reaching at the same time. If the time taken by both of them is same, let's say k o'clock, that means if this is taking x hours, this will take x minus 1 hours to cover the same distance. Clear? Now, when distance is constant, ratio of time taken is inversely proportional to the ratio of their speeds. If time taken is x and x minus 1, then speed will be inversely proportional. So, speeds become x minus 1 and x. Okay, if first car traveled for at least 6 hours, then the highest possible value of percentage by which the speed of second car could exceed the speed of first car. Now, let's see. If this is 6, then this is 5. That means the ratio of speeds becomes 5/6. Similarly, this can be 7, this can be 6, this can be 8, this can be 7 and so on, so on, so on. It can go anything. It can be 100, it can be 99 and so on, so on, so on. And this will be reversed. So this becomes 6, 7, 7, 8 and so on, so on, so on. This will be 99 and now the question is asking you the greatest percentage change. Now the greatest percentage change will happen. Now what is the percentage change? That's final value minus initial value by initial value into 100. Now observe that the gap between final value and initial value is 1 always. That means the numerator is constant. Now the percentage value will be greatest when the denominator is the least. And where is the denominator least? The denominator is least here at 5. So therefore, this would be my preferred choice here. 1 by 5 into 100, this becomes 20%. So this will be the greatest possible value of percentage change between the speed of the second car and the speed of the first car here. Clear? So this is a very interesting question. All we have to understand is that the gap is 1 always. If the gap is 1, then how do we ensure that we are getting the greatest percentage change? Right? Let's look at the next question, please. Now, points A, P, Q, B lie on the same line. Okay. So we have A, we have P, we have Q, and we have P. All of them lie on the same line. Okay, respectively. They are 100 kilometers away from A. Q is 200 from A, that means PQ is also 100. And B is 300 from A, that means QB is also 100. Clear? Now, cars 1 and 2 leave A at the same time and move towards B. Simultaneously, car 3 leaves B and move towards A. That means all of them are starting together. Car 1, car 2 and car 3. If all of them are starting together and I'm told that car 3 meets. Now understand, when two bodies start together, and they meet, what can I comment, guys? I can comment that time is constant. Now, if time is constant, then we know that the ratio of speeds is directly proportional to the ratio of their distances covered. Now, to let car 3 meets car 1, so I can say that the ratio of C3 by C1, that is the speeds, okay, is equal to car 3 meets car 1 at Q. So, by the time car 3 covers 100, car 1 covers 200. Similarly, it meets car 2 at P. That means by the time car 3 covers 200, car 2 covers only 100. So, what do I have here? I have C3 by C1 is equal to 1:2. And I have C3 by C2 is equal to 2:1. C3 is common. So, let's make them numerically same into 2 into 2. So, my final ratio is C1 is to C2 is to C3 is 4 is to 1 is to 2. This is my final conclusion. Now, what is the question asking you? Find the ratio of car 2 is to car 1. Now, we can see that car 2 is to car 1 is in the ratio of 1:4 and 1:4 becomes our final answer here. Okay, guys. Let's look at the next question, please. Now, a train traveled at 1/3 of its usual speed and hence it reached its destination late by 30 minutes after the scheduled time. Okay. On its return journey, the train initially traveled at its usual speed for 5 minutes and then stopped for 4 minutes. The percentage by which the train must now increase its speed so as to reach the destination on scheduled time. Now, this is the best example of proportionality again. The distance covered is constant in both the cases. And the best part is the question is not talking about distance. Therefore, we use speed is inversely proportional to time. Now, let's see. What is S1 is to S2? The car is traveling at 1/3 of the speed. So, if S1 is equal to 3, then S2 becomes 1. If speed is 3 is to 1, time taken becomes 1 is to 3. Now, what is the question saying? It reached 30 minutes later than the scheduled time. So, if this is K, this is 3K. That means the gap of 2K is equal to 30 minutes or the value of K is equal to 15. Okay. Now, initially the train traveled at its usual speed for 5 minutes. So, let me define the distance here. So, this is K is 15. So, I can say distance is 3 into K. So, I can define my distance is equal to 3 into 15, let's say 45, some unit which is uniform, no problem. Now, 45, yeah. The train initially traveled at its usual speed for 5 minutes. Usual speed is 3 parts. So, the train traveled D1 is equal to 5 into 3, that is 15. And then stopped for 4 minutes. That means again it stopped for 4 minutes. So, total time has taken has been 9 minutes. And total distance covered is 15. Now the percentage by which the train must increase its usual speed to reach the destination on scheduled time. That means now the train has to cover the gap of 30 kilometers in a usual time of 6 minutes. That means the speed now should be 5. So the earlier speed was 3 and the new speed is 5. That means by what percentage will it increase? That's final value minus initial value by initial value into 100. So 2 by 3 becomes 66.67 percentage, or it's approximately 67 percentage, and that becomes our required answer. So therefore the percentage change should be 67 here. Right? Let's look at the next question here. Now, trains A and B start traveling at the same time towards each other with constant speeds from X and Y respectively. Okay. Train A reaches Y in 10 minutes, whereas train B takes 9 minutes to reach X after meeting train A. Let's see. I'm given two trains, so let's try to understand the gap here. The stations are X and Y. And let's say this is the meeting point M. So train A starts from here and train B starts from here, and I'm marking the same point here. This is M. Now total time taken by train A to reach from X to Y is 10 minutes, whereas I'm told that train B takes 9 minutes to reach from after the meeting point. Now let me assume that the time taken by train A for the first part of the journey is T, because both of them are starting together and both of them are meeting. The time taken by train B for this part of the journey also becomes T. I repeat, both of them start, both of them meet. So the time taken by both of them is always same. Right? And I know that the total time taken is 10 minutes. So this part of the journey becomes 10 minus T. Now let's understand the distance AM is constant. Sorry, XM is constant. Clear? So if the distance XM is constant, so time taken by A divided by time taken by B is equal to T by 9, which should be equal to, so therefore this implies speed of A by speed of B will be 9 by T, because time is inversely proportional to speed. Similarly, if I take distance My as constant, Ta by Tb for this part of the journey is equal to 10 minus T by T. So therefore Sa by Sb will be equal to T by 9, sorry, T by 10 minus T. And both of them are traveling at constant speed. So I can equate both of them and I can say that this is 9 by T is equal to T divided by 10 minus T. So what do we have here? We have T square is equal to 90 minus 90, or we have T square plus 90 minus 90 is equal to 0. So we can take this as plus 15T minus 60 minus 90 is equal to 0. So eventually what do we have here? We have T plus 15 into T minus 6 is equal to 0. So since time T is the time taken, so therefore the value of T should be 6 and not minus 15. So this is 6, this is 4, this is 6, and this is 9. What is the question asking you? Find the total time in minutes by train B to travel Y from X. So time taken by B to travel Y from X is equal to 9 plus 6. That is 15 minutes, and that becomes our required answer. So this completes our lot on the proportionality as well. Clear? Again, the simple thing, whatever you are learning in the concepts, you are trying to see how do we apply in the real CAT questions and how do we see that the questions are being made easy. Right? Let's move to the next model, which is relative speed. Now, what is relative speed? What are the points to remember with respect to relative speed? Now, I use relative speed when two bodies are moving independent of each other. So, two freely moving bodies are moving. Two freely moving bodies. Okay. Now, in relative speed, what are the things that I need to keep in mind? I need to understand the direction in which they are moving. If both of them are moving in same direction, then the relative speed becomes speed of faster. minus speed of slower, and generally the overtaking is happening here. Okay. Right? And if both the bodies are moving in opposite direction, then the relative speed becomes speed of faster plus the speed of slower. Now, we need to understand there's a term called relative distance. Now, that is the distance separating both the bodies at the same time. Now, this is something which is more important. We apply relative speed only when I calculate the distance which is separating them in the same time. Now, in this case, with respect to the object starting later is to be considered, and the distance separating both of them at that point in time is to be considered. Okay, we'll look at this with an example as well. And the third point that we need to keep in mind is time taken to meet. Now, time taken to meet is relative distance upon relative speed. Right. Now, we need to understand that relative speed can also be used by applying the proportionality concept of time is equal to constant. But when the question is asking us the time taken to meet, then we preferably use relative speed in the scenario. Right. So, let's look at the questions now. Now, on a long stretch of east-west road, A and B are 2 points which are such that B is 350 kilometers to the west of A. So, B is to the west of A. So, I have B here, I have A here, and this stretch is going to be 350 kilometers long. Okay. Now, one car starts from A and the another starts from B. If they move towards each other, they meet after 1 hour. Now, what is the distance separating them? Clear, the distance separating them is 350 because both of them are starting at the same time, right? So, the car 1 is starting from here and let's say car 2 is starting from here. Since they are starting together, the relative distance here becomes 350. So, time taken to meet, that is 1 hour, is equal to relative distance, that is 350 divided by both of them are moving in opposite direction. That means that becomes speed of car 1 plus speed of car 2. Clear? Or from here we get speed of car 1 plus speed of car 2 is equal to 350 kilometers an hour. Now, if they both move towards east, then they meet after 7 hours. Now, when they are both moving in the same direction towards east, they are meeting after 7 hours, right? Again, the relative distance is 350 divided by C1 minus C2 is equal to 7 hours. So, from here if I simplify, I get C1 minus C2 is equal to 50 kilometers an hour. Now, either I equate both of them to calculate C1 and C2 individually, but please understand the question is not asking that. The question is asking you find the difference between their speeds in kilometers an hour. So, the difference between their speeds in kilometers an hour is already given to us, that is 50, and therefore my answer here becomes 50 kilometers an hour becomes your answer. Right, so very easy question. All we need to understand is relative distance, relative speed, time taken to meet. Three simple things and this concept becomes easy. Now, let's look at this question. Now, A and B are two railway stations 90 kilometers apart. Okay. So, I have A and B which are two railway stations and they are 90 kilometers apart. A train leaves A at 9 a.m. heading towards B at a speed of 40 kilometers an hour. Let's say train 1 leaves at 9 o'clock at a speed of 40 kilometers an hour. Another train leaves B, that is T2, at 10:30 and heading at 20 kilometers an hour. Find the time the trains meet each other at what time. So, we know very simple that the formula is time taken to meet is equal to relative distance upon relative speed. Now, this is where the relative distance comes very handy. I have train 1 starting at 9 o'clock, I have train 2 starting at 10:30. So, we will consider 10:30 as our reference point. Remember, we had seen the train, the body starting late is to be referred. So, at 10:30, that means in 1.5 hours, this train would have covered 1.5 into 40. That's 1.5 into 40, 1.5 into 40 becomes 60. So, T1 is here at 10:30, moving at 40 kilometers an hour. And at 10:30, the distance separating both of them is going to be 30 kilometers because total distance is 90. So, this becomes my relative distance. And both the bodies are moving in opposite direction. Therefore, the speed becomes the sum of their speeds. 30 by 60 becomes half an hour. Now, after half an hour, they'll meet. Now, half an hour from what time? Half an hour from 10:30 they will meet, right? So, half an hour from 10:30, which means they are going to meet at 11 a.m. and therefore 11 a.m. becomes our required answer. So, again repeat guys, relative distance is the distance separating both the bodies at the same time. And we need to consider the person who is starting late. That becomes our reference point here. Now, two cars travel from different locations at different speeds, okay, at constant speeds. To meet each other after starting at the same time, they take 1.5 hours if they travel towards each other. Now again the same logic. So let's say distance separating them is d divided by, let's say, car A plus car B, because they're moving in opposite direction, and this becomes 1.5 hours. Clear? And if they travel, but 10.5 hours if they travel in the same direction, that means d divided by A minus B is equal to 10.5 hours. Now the speed of the slower car is 60 kilometers an hour. So we are already given the speed of the slower car. So let's try to apply that. So speed of the slower car, let me assume that is B here. So we'll consider the speed of the slower car to be 60. So what do we have here? So we have A plus 60 and we have A minus 60. Okay. Is equal to this. Right. Now let's look at what is the question asking us. The question is asking us the distance traveled in kilometers by the slower car. Slower car speed is 60. When it meets the other car while traveling towards each other. Now when they're traveling towards each other, if they're meeting after 1.5 hours, that means can I say the slower car has traveled for 1.5 hours? Let's say they start from here and they meet somewhere here. So this distance is equal to 1.5 into 60. And this distance will be 1.5 into A, because both of them started at the same time and both of them met. So I am asked the distance traveled by the slower car when it meets the other car. That's going to be simplifiably 60 into 1.5. That is going to be 90 kilometers should be our required answer. So we don't need to solve anything beyond this, and we will get our answer in an easy manner. Right. So let's look at the next concept. The next concept is linear races. Right. Now in linear races, we generally apply time is equal to constant model. Now in a 100 meters race, if I'm given A beats B by 20 meters, then all we need to keep in mind is A beats B. That means A is at the finishing point. This is something which is very important. Okay. So A is at the finishing point and A beats B by 20 meters. That means B is 20 meters behind A. So both of them have started the race here. So what can I conclude? The time in which A covers 100 meters, in that time B covers 80 meters. Now when time is equal to constant, we apply that distance is directly proportional to speed. Okay. So therefore, the distance covered by A divided by distance covered by B should be equal to speed of A divided by speed of B, which is equal to 100 divided by 80, and we get it as 5 by 4. Now this is a standard concept that we apply in races. Clear? When distance is given to us. Now in a 100 meters race, A beats B by 20 seconds. Now what do I mean by that? That means A has finished the race. B has to run for 20 seconds to finish the race. That means this distance has to be run by B in 20 seconds. So I can say that this distance is equal to 20 into B. This is one part I can say. Or I can say that if A completes the race in X seconds, B will complete the same race in X plus 20 more seconds, because in X seconds, if A has covered this distance, in X seconds, B has covered only this part of the distance. So this is in X seconds and this is in X seconds, and I know that B will run for 20 more seconds to complete the race. So therefore, the total time taken by B becomes X plus 20 and the total time taken by A becomes X. If I'm commenting on the distance, I can say that this part of the distance is equal to 20 into B. Now these are the two generalized statements that we need to understand. Once we know this, we should be able to solve linear races very easily. Let's look at the questions. Now in a race of 3 horses, for the first beats second by 11 meters and third by 90 meters. So let's understand. The first beats second. Let's say A is the first guy. He beats second by 11 meters and he beats third by 90 meters. So third by 90. So this part becomes 79. But I'm not bothered about that. So I can say one thing, that when A covers the complete length of the track, B will cover L minus 11 and C will cover L minus 90. When A has reached the finishing point, B is 11 meters behind and C is 90 meters behind the winner. if the second beats third by 80 meters. Now understand, if the second beats third, that means now the second one has completed the race and he is beating the third by 80 meters. That means I can say that when B has, so this is the ratio of the speeds, okay? The ratio of the distances is the ratio of the speeds. Now when B has covered L, C has covered L minus 8. This is also the ratio of their speeds. So what can I comment here? That the ratio of the speeds of B and C are same. So we can write this as L minus 11 by L minus 90 is equal to L divided by L minus 80. So this becomes, so if I simplify this, let's calculate it here. If I simplify this, this becomes L square minus 91L plus 880 is equal to L square minus 90L. So L square and L square gets cancelled. When we transpose the values, we get the value of L is equal to 880, and that is going to be the length of the race. And that's what is asked in the question. The length of the race is going to be 880 meters. Clear? So standard question, I repeat, all we have to do is equate the ratio of distances should be equal to the ratio of their speeds. Let's look at one more CAT question. In a car race, A beats B by 45 kilometers and B beats C by 50 kilometers. And car A beats C by 90 kilometers again. So I'm talking about A beats B. So we can say that when A covers the complete length of the track, B covers L minus 45, and I'm told that A beats C by 90, but that means when A covers L, C covers L minus 90. Now this becomes the ratio of their distances, which is nothing but the ratio of their speeds. Clear? Now car B beats C by 50 kilometers. So when B covers L, C covers L minus 50. Again the same logic, the ratio of B and C, the speeds of B and C is same. So we can write this as L minus 45 divided by L minus 90 is equal to L divided by L minus 50. So we get L square minus 95L plus 45 into 50 is equal to L square minus 90L. L square gets cancelled. So we have 5L is equal to 45 into 50, or 5 ones are 5 tens are, which means the length of the race is going to be 450 meters. And what is the question asking us? The question, sorry, 450 kilometers. What is the question asking us? The question asking us the distance in kilometers for which the race has been conducted, and therefore the race has been conducted for 450 kilometers. Right? Now let's look at the another model that we are looking at here is given the time taken to reach the opposite end after meeting. Let's take a simple example to understand this. Okay. So P and Q start from two distinct points A and B and travel towards each other. They meet C and continue their respective paths. P takes 25. So P and Q start together. Now these are the hints. Okay, two bodies start together and two bodies meet. Let's say these are the points A and B. P and Q start simultaneously. These are some keywords of this model, towards each other, and they meet at a point called C. Let's say they meet at a point called C. So how is this model derived? I'll come down to the shortcut, but let's understand the derivation, because if the question becomes slightly difficult, then the derivation becomes very important. Okay. So the derivation has come from the fact that time taken by P to cover the distance AC is equal to time taken by Q to cover the distance BC. So time taken is nothing but AC divided by speed of P is equal to BC divided by the speed of Q. I repeat, P and Q are the speeds of both P and Q. Clear? Now, they continue their respective paths. Now, this is the most important point. Okay, this is where this model is based upon. P takes 25 minutes to cover this distance. Now, this distance is covered by P in 25 minutes. Let me assume this as 25 into speed of P. So, BC becomes 25 into P and AC becomes 16 into Q. Now, this is what the model says, the time taken to reach the opposite end after meeting. So, if I replace these values of AC and BC here, let's understand. So, AC becomes 16Q divided by P is equal to 25P divided by Q. So, when we cross multiply, we get P square by Q square is equal to 16 by 25. or P by Q is equal to root over of 16 by 25. So you can remember this model. Whenever such kind of model is asked, speed of A divided by speed of B is always equal to square root of time taken by B divided by time taken by A. And I repeat, here the time taken is nothing but the time taken to reach the opposite end after meeting. So it's a very important model. 2 to 3 questions have come from this model. So it's very important, it's very important for us to remember this model, because in case another question repeats, it should be a jackpot situation to us. Right, let's look at this. Now A and B are 2 points on a straight line. Ram runs from A to B while Rahim runs from B to A. Okay. So I have Ram starting from here and I have Rahim starting from here. Okay. After crossing each other, let's say they cross somewhere each other. Now their destinations and reach their destination. So Ram is taking 1 minute to reach from here to here. And Rahim is taking 4 minutes to reach from here to here. So we know from the formula that speed of Ram divided by speed of Rahim is equal to square root of time taken by Rahim inversely proportional, okay, divided by time taken by Ram. And that is going to be square root of 4:1, which will eventually give you 2:1 as the ratio of Ram's speed is to Rahim's speed. And that's what the question is asking us. Find the ratio of Ram's speed and Rahim's speed. Therefore, the answer becomes 2:1. So if you know this shortcut, you get the answer in fraction of seconds and get your final answer in the examination. Clear? Let's look at one more question. Now a straight road connects points A and B. Car 1 travels from A to B and car 2 travels from B to A, both leaving at the same time. Okay. So I have two cars. So we have car 1 and we have car 2. After meeting each other, they take 45 minutes. So car 1 is taking 45 minutes to reach the other end, and car 2 is taking 20 minutes to reach the other end. Right, so I know that speed of car 1 divided by speed of car 2 is equal to square root of time taken by car 2 divided by time taken by car 1. That is equal to 20 by 45. And 20 by 45 is going to be 4 by 9. So square root of 4 by 9 will give you 2 by 3. Now what is the question asking us? If the speed of car 1 is 60, so we can equate 60 divided by speed of car 2 is equal to 2 by 3. So 2 ones are 2 30s are, which means speed of car 2 is eventually going to be 30 into 3, that is going to be 90 kilometers an hour. And that's what the question is asking you. Find the speed of car 2. So the speed of car 2 is going to be 90 kilometers an hour. Right. So again, very important model seen. So if we know the shortcut, job becomes pretty easy for us. Now let's look at the next model. Now this model is talking about trains. So a train crosses a man or a pole or a bird or a point, right? In this case, the length of the object is assumed to be 0. Then the total distance covered is the length of the train. Clear? Similarly, a train crosses a platform or a bridge or a tunnel or another train where the distance covered is the length of the train plus the length of the object. Simple two models. And if the object that the train is crossing is moving, then we start using relative speed. So it's a very easy model of trains. One case where the length of the object is assumed to be 0. In the other case where we have a substantial length of the object, and if the object is moving, we assume we start applying relative speed. Right? Now let's look at the questions. Now, two trains cross each other in 14 seconds when they are running in opposite direction along the parallel tracks. When two trains cross each other, the total distance covered is length of train 1 plus length of train 2. Clear? The faster one is 160 meters long and crosses a lamp post in 12 seconds. We'll come back to that. So let's understand. So what are we given here? We are given the length of the fastest train. So one train is 160 meters long. I do not know the length of train 2. Clear? Divided by the speed of train 1 plus speed of train 2, and this total time is equal to 14 seconds. This is what we have in the first case. Now, the second sentence says the faster train crosses a lamp post. Whenever the train is crossing a lamp post, the total distance is covered is equal to the length of the train. That means 160 meters divided by 12 will give me speed of the first train. And that becomes how much? 40 divided by 3. The speed of first train is 40 by 3. Now, the speed of the other train is 6 kilometers an hour less than the faster train. This is my faster train, okay. Now 6 kilometers an hour. So speed of the second train is equal to 40 by 3 meters per second. This is meters per second. Minus 6 kilometers an hour will be in meters per second. So I am converting into 5 by 18. So this becomes 6 ones are 6 threes are. That means S2. We will get it as 35 by 3 meters per second. So we have S1 and S2 as well. So we can apply in the formula here. So what is S1 plus S2 finally? So we write S1 plus S2 is equal to 45 plus 30, sorry 40 plus 35 divided by 3. That is 75 by 3, which will give us 25. So we can write this as 160 plus L2 divided by 25 is equal to 14. Or we have 160 plus L2 is equal to 25 into 14. We can break 25 into 14 as 25 into 10 plus 4. Now 25 into 10 is 250. 25 into 4 is 100. So 250 plus 100 is 350. So we have 160 plus L2 is equal to 350, or eventually we have L2 is equal to 350 minus 160, and our final answer here becomes 190 meters. And therefore the length of the train 2 will be 190 meters. A very simple question. All we have to understand is when the train is crossing an object of a specified length, the total distance covered is length of the length of the train plus the length of the object. And if the train is crossing an object of no length or insignificant length, we assume the total distance covered is the length of the train only. Right? Let's look at the next question. Now, two trains A and B moving in opposite direction, their speeds are in the ratio of 5:3. Okay. The front end of A crossed the rear end of B after 46 seconds. Now, what is happening? The front end of A, that means I'm only looking at this point. Let's say front end of A is X and this is Y. This is A, okay? And let's say we're talking about train B. And train B is, let's say, front end is P and rear end is Q, okay? Now, when I'm saying two trains are moving in opposite direction, we assume the scenario to be something like this. This is when the timer starts. So let's say this is X, this is Y, and this is P, and this is Q. Now I'm told the front end of A, that is X, crosses the rear end of B, that is Q. That means only these 2 points are crossing each other. So if X is crossing Q, that means the distance covered is the length of the smaller train. Clear? Right? So let's say length of smaller train is the length of B divided by, both of them are moving in opposite direction. That means speed of A plus speed of B, and this total time taken is going to be how many seconds? 46 seconds. Clear? 46 seconds after the front ends of the train crossed each other. Right, now it took another 69 seconds for the rear ends to cross each other. So from this point in time, if I want both the rear ends to cross each other, clear? So from this point, if I want the rear ends to cross each other, that means Y has to cross this. So if I keep on moving forward, so Q will cover the length of train A, right? Only in that case the rear ends will cross each other. This point has to cross this. So this point will keep on moving and has to cross this. Okay, guys? So in that case, we have length of A, and since both of them are moving in opposite direction again, speed of A plus speed of B, and this is going to be a total of 69 seconds. Another question is asking you find the ratio of the length of both the trains. So length of A to length of B. So this gets cancelled. So eventually what do we have? This is 23 2s and 23 3s. So we have LB by LA is equal to 2 by 3, or we want LA by LB. So LA by LB eventually becomes 3 by 2. So therefore 3:2 becomes our required answer. Clear? So not a very difficult question, a very easy question. All we have to understand is the rear ends cross each other. Right? So that in 69 seconds when the rear ends are crossing each other, clear? That means it's covering the length of the train A. Clear? Let's move to the next question, please. Now, two persons are walking beside a railway track at respective speeds of 2 kilometers an hour and 4 kilometers an hour in the same direction. Okay. A train comes from behind and crosses them in 90 seconds and 100 seconds. So that becomes the length of the train divided by speed of the train. I do not know speed of the train. Let's say S kilometers an hour minus 2. Clear? And this becomes 90 seconds. Okay. So that is kilometers an hour. So all we can do is we can multiply it with 5 by 18 here. Let's say L is in meters. This is kilometers an hour. So this becomes 5 by 18. So 18 ones are 18 fives are. So we get the length of the train is equal to 5 fives are, that is 25s minus 25 twos are 50. Clear? Now same train cross the second man, that is S minus 4 into 5 by 18, and this time the time taken is going to be 100 seconds. Clear? So length is 25s minus 50. Let's simplify this. This is 2 9s and 2 50s. So this eventually gives us what here? Now this gives us length is equal to 5 into 50 is 250. That becomes 250s minus 250 into 4, that is 1000, divided by 9. So we can equate both of them. So once I equate both of them, I get 25s minus 50 is equal to 250s minus 1000 divided by 9. Or we cross multiply, this becomes 225s minus 450 is equal to 250s minus 1000. We transpose the values, so we get 25s is equal to 550, or the value of s is equal to 22. So I repeat, this is 22 kilometers an hour. That is the speed of the train. Okay. If the speed of the train is 22 kilometers an hour, let's talk about the length of the train. The length of the train will be 25 into 22 minus 50. So 25 into 22 is going to be 550. 550 minus 50 is going to be 500. So the length of the train is equal to 500 meters. And how many seconds does this cross? That is 500 divided by 22 into 5 by 18. This is 5 ones are 5 hundreds are. This is 2 nines are 2 11s are. So this can be written as 9 by 11 as a percentage. Now we know that 9 by 11 is a multiple of 9. 9 nines are 81. That is 81.81 percentage. So 81.81 is approximately 82 seconds, and therefore 82 seconds becomes our required answer. Clear? So again, a very simple question. We have to understand is three simple things: a train crossing an object of specific length, a train crossing an object of no length, and the third important point is if two bodies are moving, we apply relative speed and we come out with our answers. Right? Now the next model is a very important model which is called escalators. Now we need to understand when a person is moving in the same direction of escalator, then the speed becomes speed of the person plus speed of the escalator. Right? This is more like the boats and streams kind of question. When the person is moving in the opposite direction of escalator, then this becomes speed of the person minus speed of the escalator. Right? Now time is constant, which means the time for which both the bodies are moving, that is the person and the escalator, is always same. And that's why the formula that we look at is the number of steps is the time taken for both of bodies is same. That is speed of person 1 plus or minus speed of the escalator, which is equal to, let's say T1, T2 into speed of person 2 plus or minus speed of escalator. This becomes our required answer. So let's look at the question here. Now, Moody takes 30 seconds to finish riding an escalator if he walks at a normal speed in the same direction. So time taken is constant. Clear? That's the speed of Moody and is moving in the same direction. That's the speed of escalator. He takes 20 seconds to finish riding the escalator if he walks at twice the normal speed. Okay. This time the time taken is 20. He is moving at twice the normal speed. Again in the same direction of the escalator. So this is what is happening. Clear? Then the time in seconds that is needed. So this is the number of steps in the escalator. Let's equate both of them. So 0, 0 gets cancelled. So we get 3 SM plus 3 SE is equal to 2 2s are, that is 4 SM plus 2 SE. So to simplify, we get speed of the escalator is equal to the speed of Moody. That is equal to x. So my number of steps here becomes 30 into 2x, which is equal to 60x. Now what is the question asking us? The question is asking us, if Moody decides to stand still on the escalator, then the time taken in seconds needed to finish riding the escalator. That means he is not moving, only the escalator is moving. Clear? Right? But doesn't matter because speeds are same in both the cases. So we get 60x by x, x and x gets cancelled. So therefore, the time taken becomes 60 seconds when the escalator is, when the person is standing still and only the escalator is moving on the top. Clear? So very basic model. If a question comes from this, we should not be hesitating to get our answer. It's a very easy model and we should be able to get our required answers. Right? Now the last model of this topic, which is a very important topic, which is called circular tracks. Right? Now time taken to meet for the first time, if their bodies are moving in opposite direction, and that becomes the length of the track divided by speed of A plus speed of B. If the bodies are moving in same direction, then again that becomes length of the track divided by speed of A minus speed of B, or faster minus slower. Now sometimes the question might ask you, find the time taken to meet for the nth time. If I want to take the time taken for me to meet for the nth time, that becomes into n, and this also becomes into n. For example, if the first meeting is happening after 15 seconds, then the second meeting will happen after 30 seconds, third meeting will happen after 45 seconds, and so on and so on and so on. Clear? Now time taken to meet for the first time at starting point. Now when it says starting point, it is irrespective of directions. The answer will be same irrespective of directions. Okay. So the time taken is going to be the LCM of time taken by A to complete one round, comma time taken by B to complete one round, and so on and so on and so on. Clear? The next thing that we need to keep in mind is that how many distinct points will the meeting take place if they are moving in same direction. So I repeat, make their speeds in the ratio of A is to B. If they are moving in same direction, then the number of distinct points is, let's say, A minus B mod. Doesn't matter whichever is larger. And if they are moving in opposite direction, then the number of distinct meeting points becomes A plus. Clear? One more point that I have not written here, which we also need to understand, is time taken by three of them to meet. Whenever the question is asking you time taken by three of them to meet, we need to understand it's very simple. It is going to be LCM of time taken by AB to meet, comma time taken by BC to meet, comma time taken by AC to meet, will give you the time taken by all the three of them to meet. Clear? So let's move to the next question now. Now two ants A and B start from a point P on a circle at the same time. A is moving clockwise and B is moving anti-clockwise. Okay. They meet for the first time at 10 a.m. Okay, and A covers 60% of the track. If A returns P at 10:12, find the time after which B returns P. Okay, now let's try to understand this question. Let's say this is the point P. A is moving in this direction and B is moving in this direction, and let's say they met somewhere here. Now, whenever they meet, we know that time is constant. They start together and they meet, that means time is constant. So what is the ratio of distances? Distance covered by A is to distance covered by B. So A covered 60% of the track, let's say of the length of the track. and B covers 40% of the length of the track. So L gets cancelled, this gets cancelled. So the ratio of the distances is going to be 3:2. Clear? Which will also be the ratio of their speeds. So the ratio of speeds of A is to speeds of B is equal to 3:2. We can conclude one thing here. Clear? Now let's look at it with a slightly different dimension. What am I given? I'm told that A returns P at 10:12 p.m. So they met here at 10 o'clock and they reached P at 10:12, which means, can I say A covered 40% of the track in 12 minutes? That means A will cover 100% of the track in how much time? 100% of the track A will cover, or yeah, we can look at that, no? Yeah. So 100% of the track A will cover in 12 plus 12 plus 6, that is 30 minutes, right? Yeah. That's what we have. Yeah, 40% plus 40% plus 20%, that is 12 plus 12 plus 6, that is 30 minutes. Right. Now, this is the time taken by A to cover one complete track. Now tell me, when distance is constant, I know that ratio of speeds is inversely proportional to the ratio of time. So can I say time taken by A divided by time taken by B to cover one complete track is going to be 2:3? And I know that A takes 30 minutes. I do not know the time taken by B. So this is 2 ones are 2 15s are. So time taken by B becomes 45 minutes. But this is to complete one length of the track. But if you understand, if B has to reach P, B has to only cover 60% of the track. So if 100% of the track is in 45 minutes, then 60% of the track we will cover in 3 by 5 of 45. That is 5 ones are 5 nines are. That is 27 minutes after 10 a.m. So 27 minutes after 10 a.m., which means B will reach P at 10:27 a.m. So very interesting question. Two bodies start, two bodies meet, right? We are given certain portion of the distances covered in certain time, and from there we again use distance as constant and get our final answer. So very interesting question. Must understand the question in the examination and get the answer. Now John jogs track A at 6 kilometers an hour and Mary jogs at 7.5 kilometers an hour, track B. So there are two tracks. Okay. The length of tracks A and B is 325. While John makes 9 rounds of track A, that means the time in which John makes 9 rounds of track A, in the same time Mary makes 5 rounds of track B. Okay. So we are given speeds, we are given the total length, and I'm asked in how many seconds will Mary cover one round of track A. So very important concepts. Okay, now let me assume the length of track A is equal to x meters and length of track B here eventually becomes 325 minus x meter. Okay. Now the time in which John covers 9 rounds of track A. Okay. So what is the total distance? The total distance is 9 into x. Clear? Right? Divided by 6 kilometers an hour becomes the time taken, distance by speed. 6 can be written as into 5 by 80. In the same time, right? So this time is as same as the time taken by B to cover, Mary to cover 5 rounds of track B. So this becomes 5 into 325 minus x divided by 7.5 into 5 by 18. So 5 by 18, 5 by 18 gets cancelled. This can be written as 75 by 10. I'm taking 10 in the top. So this is 3 twos are, and this goes up with 3 into 25s. This is 5 twos are, and this is 5 fives are. And this 5 and this 5 eventually get cancelled. When cross multiply, so what do we have? We have 9x is equal to 4 into 325 minus 4x. Or we have 13x is equal to 4 into 325. Or we have the value of x is equal to 4 into 325 divided by 13. So this is 13 2s are 26, 65, 13 5s are 65. So the value of x here is going to be 100 meters. That is track A. So we got the length of track A. Now the question is asking you, Mary covers one round of track A. Now Mary is covering at a speed of 7.5. So let's write 75 by 10. And this is in kilometers an hour, that is 5 by 18. So this is 25 4s are, 25 3s are, 3 1s are, 3 6s are, 5 1s are, 5 2s are. 4 2s are 8, 8 6s are 48. So therefore in 48 seconds, Mary will cover one round of track A. That becomes our required answer. So not a difficult question at all. We had to just understand that one single statement, that time is equal to constant, and we should have got our required answer. Clear? Now let's look at the next question. Two circular tracks T1 and T2 of radii 100 and 20 respectively touch each other at point A. Okay. So I have 100 and I have a radii of 20. And they touch each other at point A. Starting from here, Ram and Rahim walk on track 1. So Ram is moving on track 1 and Rahim is moving on track 2 at speeds of 15 kilometers an hour and 5 kilometers an hour respectively. The number of full rounds that Ram will make before he meets Rahim again for the first time is how much? So Ram has to meet Rahim. That means, can I say Ram and Rahim will meet at the starting point only? So the time taken to meet at the starting point is LCM of the time taken by Ram to reach the starting point as well as time taken by Rahim to reach the starting point. So this becomes 100 divided by 15 into 5 by 18. This is 5 1s are, 5 20s are, 5 4s are, 5 3s are, 3 1s are, 3 6 are. That is 24, comma. And this is 20 divided by 5 into 5 by 18. This is 5 1s are, 5 4s are. That is 72 by 5. So LCM of fractions will be LCM of numerators divided by HCF of denominators. So LCM of numerators will be 72 seconds. Clear? So in 72 seconds, how many rounds will Ram make? Now we know that Ram is taking 24 seconds to complete one round. This is what we got here. So if Ram is taking 24 seconds to complete one round, to complete 72 rounds, Ram will cover 3 rounds when he is meeting Rahim for the first time, and therefore the answer in this case becomes 3. Clear? So not a very difficult question here again. So we just have to understand that if they're starting from that point, they will be meeting at the starting point again. Right? So now let's look at this question. So we have Anil, Sunil and Ravi run along a circular path of length 3 kilometers, starting from the same point at the same time and going in clockwise direction. If they run at the speeds of 15, 10 and 8, how much distance in kilometers will Ravi have to run when Anil and Sunil meet for the first time at starting point? So Anil and Sunil. So let's try to understand. So Anil speed is 15 kilometers an hour. Sunil speed is 10 kmph. And Ravi's speed is 8 kmph. So Anil and Sunil meet at the starting point. So Anil and Sunil will meet at the starting point. So time taken by Anil to reach the starting point is 3 by 15. And time taken by this guy to reach the starting point is 3 by 10. Now we cannot take the LCM of this because the fraction should be in the most simplified form. So this can be further written as 1 by 5, comma 3 by 10. So LCM of numerators is 3. HCF of denominators is 5. So they are meeting after 3/5 of an hour. Now 3/5 of an hour is how many minutes? Now let's give it as 3 by 5 only. Okay. 3/5 of an hour. Now what do I have here? So all that we are looking at is, in this much time, how much distance will Ravi run? Now Ravi is running at a speed of 8 kilometers an hour. So distance covered by Ravi becomes 8 into 3 by 5. So that becomes 24 by 5, and 24 by 5 is going to be 4.8 kilometers. And therefore, the final answer here is going to be 4.8 kilometers. Okay, guys. Right. So let's look at one last question of this topic. So Meera and Amal walk along a circular track starting from the same point at the same time. If they walk in the same direction, then in 45 minutes, Amal completes 3 rounds more than Meera. Okay. If they walk in opposite directions, they meet for the first time after exactly 3 minutes. Okay. Fine. Now, I'm talking about 3 rounds more. Okay. Now, let's try to understand. Let us assume that Meera takes A minutes to complete 1 round. And similarly, Amal takes B minutes to complete 1 round. Now, what are we looking at? In 45 minutes, how many rounds will Meera cover? In 45 minutes, Meera will cover 45 by A rounds. And in 45 minutes, Amal will complete 45 by B rounds. Now, Amal completes 3 rounds more than Meera. Or let's change this slightly. I'll take Meera as B and Amal as A because there might be some confusion. So, yeah. So, Meera is B minutes per round and Amal is A. So, Amal takes, so the number of rounds by Amal is 3 more than the number of rounds with Meera. Or this can be written as 45 by A minus 45 by B is equal to 3. Or we can write this as 1 by A minus 1 by B is equal to 3 by 45. That is 1 by 50. Right. This is when they are moving in same direction. Now we know that when two bodies are moving in opposite direction. Okay. When two bodies are moving in opposite direction, the sum of the rounds is always 1. Okay. So in 3 minutes, Amal will complete 3 by A rounds. Similarly, in 3 minutes, Meera will complete 3 by B rounds and this is equal to 1. So what do we have from here? We have 1 by A plus 1 by B is equal to 1 by 3. Now I want the number of rounds taken by Meera in 1 hour. So let's say minus, minus and minus. So this gets cancelled. You have this becomes minus 2 by B is equal to this is into 5 into 5. So 5 by 15. So this becomes minus 4 by 15. Minus minus gets cancelled. 2 ones are 2 twos are. That means the time taken by Meera to complete 1 round is 15 by 2 minutes. 1 round. Or we can say 15 minutes to cover 2 rounds. Similarly, I want in 1 hour, that is 60 minutes. Therefore, Meera will cover how many rounds? 8 rounds is the total number of rounds that Meera will cover in 60 minutes. Okay, guys, so this is all about this chapter, speed, time and distance. And all I would advise you is go through the models once again. Keep this video very handy, right? And revise the concepts before the examination. I'm sure that you will be able to see some great things happening in the examination. You should be able to capitalize on the questions coming up from speed, time and distance in the examination. So that's it from my side. We'll be coming up with the next video very soon. All the best. Thank you guys. Take care.